Hello programmers, welcome to the video. Today we will be solving day 11, 11th of October, daily Leetcode challenge. So directly jump into the problem. Today's problem is saying maximum total damage with spell casting. Okay, so let's understand the question first. Question is saying a magician has various spells and you are given an array. Okay, array power where each element represents the damage of a spell. Multiple spells can have the same damage value. It is known as the fact that if magician decide to cast a spell with damage of power I, they cannot cast any spell with damage of power I minus 2, minus 1, plus 1 and plus 2. Okay, so if I use some power, something like if I use power 5, then I will not be able to use 4, I will not be able to use 3. So minus 1, minus 2, and I will not be able to use 6 as well, and I will not be able to use 7 as well. Okay, so if I use power number 5, like power value is 5, then I will not be able to use plus 2 and plus minus 2. Okay, each spell can be cast only once, so this spell can be used only once. Okay, once we used, it will be vanished. Return the maximum possible total damage that magician gets caught. Okay, so total, we have to find the maximum of some total. Okay, so let's understand this better with some examples. So we are given example number 1 is 1 1 3 4. So we have example 1 1 3 and 4. Okay, and output is 6. How? So the maximum possible, they are casting like 1, they are casting 1, they are casting 4. Okay, so if they cast 1, they can't cast 2 and 3. If they cast they can't cast 0 and minus 1 as well. Okay, and so they can cast both of ones. Okay, with both of values same, so they can cast exactly the same values, but plus 1 plus 2 minus 1 minus 2 will not be allowed. Okay, if they cast 3, they are not able to cast 4 because, like, let me see the color here. If I cast 3 here, then I will not be able to cast 3 because it's in plus 1 range, and minus 1 because it's in minus 2 range. So 1 2 4 and 5 is, it is not able to cast. If I cast 4, then it will be able to, if I cast 4, then it will be able to cast these ones because it's in it will not be able to cast what 2 3 and 6 7, sorry, 2 3 and 5 6, 2 3 5 6. Okay, so it can cast 1, so it allowed, so we cast 1 plus 1 plus 4, and we will get answer is 6 damage we can do a maximum. Okay, so first observation we can note from here that we can cast the similar thing. Like if I am casting damage something I, if I am casting a damage of power I, then all of these power i's I can use. Okay, I want to use the maximum, right? So why should I not use all of the power i's, value of all the power i's, right? If it is 5, then I will use all the 5s in the 5s. Okay, all the 5s I will use. Okay, so let's understand the example number 2, how it is calculating 7 1 6 6. So it's 7 1 6 6. Okay, great. And damage is 13. How it is making a damage of 13? If I cast 7, I am not able to cast 6, I am not able to cast 6, I will not be able to cast what all these 7 will restrict us. If I choose 7, I will not be able to add 8 9, and I will not be able to add 5 6 8 9. Absolute difference of 2, basically. In absolute difference of 2 length, I will not be able to cast. Okay, so these 6 will be gone, but I can cast this one. 7 plus 8, 7 this one and 8, I can cast 8. Great. Okay, then if I cast, let's say 1, if I cast 1, I will be able to cast 6 as well, I will be cast able to 7 as well, but not together. I use 1, I use 6, I use 6, because 1 plus 2 and 3 I am not able to cast. 0 and minus 1 I will not be able to cast, but 6 is beyond this range, so we will be able to cast 6. And as you understood that as we explained from the previous example, we are taking all the powers because we want to maximize. If I am taking one 6, I will take another 6 as well. Okay, so all the 6 I will take. So this 6 plus 6 plus 1 will become 13. So I will take 1 6 6, then I will not be able to take 7 because 6 and 7 is within 2 distance. So I will make it 2 distance. I will name it as 2 distance. Okay, and if I use 6, okay, if I cast 6, then 6, and 7 I can't cast 1. So this is the answer, obviously, right? 116, which is 13. Correct. Okay, so let's understand the pattern here. Let's understand. So for pattern understanding, okay, so there is a group. There is a group of spells like 1 6 6 7. Okay, and we want to choose some spells, choose some powers. Okay, and maximize it, but we have to take the distance of 2. Like if I'm choosing this spell and this spell, this should be 2 steps apart, to minimum, like more than 2 step. Okay, so this should not be in the 2 step range, it should be greater than 2 step away. It can be 3 4 5. So difference between them should be big, right? Like I can't cast within two steps. Okay, and if I sort this array, then I think I will be able to cast because it's random completely, right? If I sort this array, then I will add the smallest one, then I know that I don't have to look back. Okay, I will move away, and I am sure that I will always get the bigger one, so I don't have to choose two directions, -2 -1, +2 +1. Okay, so we are going in two directions. I am like forcing it to go in one direction by sorting the array, because we are making sure that the next element will come is a bigger element only. There can't be shorter element after sorting this array. Okay. So one thing we observed that we can sort, and there is this answer is also like more dependent on this what spells we choose rather than ordering of that. So ordering is not much important. So let's clear this all, and let's make first observation, second observation. So first observation we made that we can take similar spells. Okay, all similar spells, similar power, like that, make it power. And second observation we make that we can sort this array. Okay, so let's see at the constraints level what all the constraints. So constraints are like 10 raised to power 5 and 10 raised to power 9. Okay, so each power of I can be 10 raised to power 9. So we can't make an array of power of I when we use that. So let's leave this constraint. This is just a number for us now, and this is 10 raised to power so 5. So we can do a solution by sorting in n log n at max in time complexity. We can't go n square. If I go n square, then it will be TLE. Okay, so let's consider this and let's move forward with the solution approach. Okay, so we have already made two observations here. Okay, what all observations we can make? We need unique elements, right? Unique elements. Also we need unique elements. Like let's say we have example 1 1 2 2 3 3 4 4, something like that, and many fours here. Okay, and then many fives here. After sorting we get array something like this, many fives here. Okay, so if I get these many elements, if I am choosing 4, if I traverse this array, like in the solutioning, if I traverse this array, I will traverse this 4, then this 4, this 4. So this much of traversal will be getting wasted. One thing, and we have to keep checking for each and every one, that if this is 4, then I will check for this, so this 4. So I will keep summing this 4 plus 4 plus 4. Instead of this, we can shorten this array and we can take the frequency, like 1 is occurrence 2 times, 2 occurs 2 times, 3 occurs 2 times, 4 occurs how many times? 1 2 3 4 5 6 times, and 5 occurs 1 2 3 4 5 6 times. Okay, if I choose to take 4, if I choose to take power is 4, power 4, if I am choosing, then I will add in the sum like 4 cross 6, so it will be 24. 24 I will directly sum it up rather than traversing 4 plus 4 plus 4 plus 4. It will obviously help us in getting reduced time complexity little bit of. Okay, great. So by for this what we will use a map. Okay, map of frequency. So this frequency map can help us. Okay, and after this frequency map, obviously we left with the unique elements. Like I can check each and every element's frequency in the frequency map anytime in like it's unordered map, let's say, and average time complexity is over. So I will be getting like unique elements 1, 2, 3, 4, 5 in our list. So this will be our list after sorting. Basically it will be in random order, but after sorting we will get this. Okay, 1, 2, 3, 4, 5. If I'm getting this, then I will choose, like if I'm choosing 1, I will not choose 2, I will not choose 3, I will choose 4, I will not choose 5, something like that. Okay, great. So we understood this, like we can take all similar one. So for this, let's say we are using map, and if I am taking any 4, I will multiply it with its frequency of 4. Okay, frequency of this element. So I will get the exact sum. If I am taking this power, how much power I am getting in total, because all the 4s I am taking here. We are sorting this array to reduce our search space, like -2 -1 I am eliminating. I will use +1 +2 only. It's like one direction, either minus either plus. I am using one direction, and the sorting will make sure that we are getting the bigger element each time I am moving forward, rather than juggling up with the -1 -2 absolute numbers. Okay, great. And the third observation we made that we are storing in this map, and we left with this sorted unique elements. Okay, so what power this gives us? Okay, we did each and everything. We made some observations, we made a frequency map, we use in a array, like we put it in a array. What power it gives us? Okay, so how we will traverse and how we will find the solution of this. For this, let's understand by dry running on this example, so in custom made examples as well. So let's try run on 1, 1, 3, 4. It's already sorted, so we left with the array of 1, 3 and 4 after sorting and keeping the unique elements. Okay, and when I will mark a map here, which will be storing 1 frequency as 2, 3's frequency as 1, and 4 occurrence as 1. Okay, so let's take this. I will go to 1. I will make that. If I have this array, if I have only this array, then what will be our answer? What will be our answer? If I have this one part only, our answer will be only 1 cross its frequency. Frequency is 2. So let me mark it as map of 1, which will be like 1 cross 2, 2. Okay, so I will mark this as our answer of this array like spells ending at 1. If I am having only one element, then I will have the answer. So let's make it like make spell collected of 0. Okay, if I have answer, I have two elements, something like this. This is our array, this is our search space. Now we have moved to this index. We have moved from this index to this index number 0 to 1. Okay, I want to see make spell, how much max spell I will get till 1. Okay, if I am at this point, what's the max spell I can get if I am choosing this? So here make the difference that if I am choosing this index spell, then how much max I will get. So if I am choosing 3, I can't choose 1, I can't go back. Okay, so if I am choosing 3, I will only get 3 cross map of 3, which will be like 3 cross 1, which will be 3. Okay, so I am getting more, some more spells here. Okay, great. If I so if array ending here, and if I am choosing this spell, I haven't gone beyond, so I can't say about that. But I have traversed till now I, and I am choosing this I. Then what will the maximum I will get? That's I want to calculate in this thing. Okay. Okay. Let's go to increase our set space. Let me change the color as well. So let's increase our set space. We have moved from here to index number 284. Okay. So if I have this much big of search space, then I will say that max spell I can get at second location is, I am choosing this first of all. So I will choose 4 cross map of 4 plus 4. I will go back and check that okay, which element is two distance apart. So I will go at 1, I will go to 3. So 1 is two distance apart, 3 is not. So I will not take 3, I will take 1. So 1 and its frequency. Okay, frequency. So I am taking 1. So can't I directly take this one? 2. I can take 2. Okay. Okay, and I will take 2 directly rather than using the 1 and frequency of 1. Okay, so let me explain it with another example. Let's understand it by this. Let's say we have a big array, very big array, and after some time you have moved till here. Okay, this is some I, you are here. Okay, you want to check if I am choosing this I, how much max I can get. Okay, so by choosing this I, you are making this I and map of I. That's simple approach. But you want to see what all elements are smaller than this and what's the sum of them. Okay, so if I choose I can choose this one, I can choose this one, like 2 elements. Then I can choose this one. I am free to choose this or this or this, anyone. Okay, I can choose this, and then if I am choosing this, I can't choose this one, then I will choose this, something like that. So I want to see the maximum of here, maximum till here. What's the, if my array is till here, if my array is only till here, what's max I can get? If I am getting some maximum here, let's say max element, I will let that up, because I will like extract out the max element from this remaining array with 2 elements. These 2 elements I will skip that, and I will add it in my current one. So I will get here the maximum if my array is ended here, and if I choose this, then what will be the maximum. Okay, great. So I hope you understood the problem. Let me traverse you through one more example. Let me change the color. So let's take an example of like 2, 1. Okay, there is no point in getting this random order, because we will always be like making a frequency app and sorting it. Okay, so let me take example 1. Let's say we have a array of 1, 2, 3 and 4. Simple, very simple. 1, 2, 3 and 4, and each frequency is 2. 1's frequency is 2, 2's frequency is 2, 3's frequency is 2, and 4's frequency is 2. Okay, so what will the answer till here? Array ending here, answer like I am making this, I am choosing this, and array ending here. Okay, so if array ends here, I have only this search space, I have gone only till 0 element, and this I am choosing. Okay, so I will get 1 cross map of 2, 1 frequency 2, I will get 2. So it's the 0th answer. At 0th answer I am getting this. At 1, how much I can get? So let's say we have moved till here, what we can take at location number 1, we are taking this, so 2 cross 2 obviously, plus maximum of this, given that each and every element should be smaller than 2 distance apart, like 3 distance apart or 4 distance apart, like minimum distance is 2 required. Okay, more than 2 is required, minimum distance 3 required. Okay, so this will not count, so our answer will be like only 4. Then at second location I went here, I went from here to, I went here. At third location I will take third element, cross its frequency 2, plus what max I can get from here till here. Okay, So this is like in one distance apart it will not choose, one two distance apart I will not choose, and I am not getting anything. So answer will be like 6. Let's calculate for last element. Let's calculate for 4. So let me remove this. Okay, so I am here, so I will choose 4 cross 2 obviously, plus what max I can get from the remaining array. Okay, so I will not get this 3, I will not go with this 2, I will go with this 1. So till 1, how much is the answer? Maximum I have 2, so max element I have till 2, so it will be like plus 2, it will be 8. Okay, sorry, 8 plus 2 10, so our answer will be 10. Great, but array is short, so we are not able to calculate this max element in much more length. So let's take a better example. If I, let's say, choose this 7, something like, how answer changes if I choose 7. Okay, so let me remove this 4, and let me remove this calculation here. Okay, so let me walk you through when this element is 7, this element is 7. Okay, how this challenge will our answer. Okay, so I will traverse, so let me remove this. Okay, so I am at 7, okay, so I will take 7 and its frequency 2 obviously, plus I want to maximize from this array, I want to maximize. Okay, so what I will do, I am like currently setting it here, I haven't traversed, so I will check what's the answer till here, 2, I will go ahead. What's the answer till here, 4, I will go ahead. What's the answer till here, 6, so I will take 6, because all 3 elements are eligible, because all of them are more than 2 distance apart. So I will take mix of 2 4 6, I will get 6, I will sum it up, and I will get answer as 20. Okay, I hope you got some little of gist here, that why we are traversing it. Okay, so let me walk you through a bigger example, so you will understand the traversing in a much better way. So let's take example like real numbers 2 5 7 8 9 10, something like that. Okay, this is our array, 2 5 7 8 9 10, and let's mark its frequencies as well. 2's frequency, let's mark it 2, 5's frequency. Okay, let's add one more element here, so let's add 3 as well. 3 2 3 5 7 8 9 10. Okay, so 3's frequency will be 1, 5 frequency will be like 1, 7 frequency will be like 1, 8 frequency like 1, and 9 frequency, let's increase it to 2, and 10 2, something like that. This map I have a map, and this is our example. Okay, 2 3 5 7 8 9 10. Okay, let's walk you through this. So at location 0, okay, location 0, I am calculating 2 cross its frequency 2 4, simple as that, nothing else. At location 1, we are traversing by I, so I will be like 1 here. Okay, at I equal to 1, we will get 3 cross 1 obviously, and beyond that, this is not 2 distance apart, anyone is not there, so I will get only 3. Okay, so you can see that we can get different element. This is not needed that if my array size is getting bigger and bigger, I will get more and more answer here. This answer will not be in sorted order. That's why I am taking the maximum. That's why I show this example to you. So let's example number 2. So at this I have 5 cross 1 plus. Okay, 5 cross 1. This is not 2 distance apart, this is 2 distance apart. Okay, so 2, 5 plus 2 is 7. Okay, I am getting 3. Okay, so I have calculated for this, like till 2, I have max element as 2, max element as 4. Okay, so my bad, I have to add 4 here, 4, so it will be 9. Okay, so I will keep another pointer, right? That I have till here I have traversed, and till here I have max out, I have calculated the solution, what will be the max. Okay, you will hope understand better with while we traverse ahead with these answers. So let's run ahead. So 7 cross 1, okay, plus plus. Now I want to traverse it again, okay. So I will traverse till 2, I will traverse for 3, I will traverse for 5, I will traverse for only. So 5 is not two distance apart, so I will leave it. 3 is two distance apart, so I will take. So 2 it's 4, for 3 it's 3. So I will take maximum of both of them, 4 and 3, it will be 4. So 7 plus 4, I will get 11 is the answer, okay. Now I have traversed till 2 and 3. For 5 I am traversing 2. For 7 I am traversing 2 again. So I am traversing this 2 again and again. And for this 3 I have traversed it once. Okay, let's move ahead and you will get more clarity. I will change the color here for simplicity. Okay, so let's traverse for fourth index. It will be like 8 cross 1. So 8 plus I will now have to traverse 2, 3, 5, 7. These 4 elements. I have traversed 2 again. But again I am traversing here. Again I am checking what's the maximum of 4, 3, 9. Because 7 is not needed. 7 is one distance apart. I will leave that. But for these 3 I need to check. So 4, 3, 9. What's the maximum? 9. How I will get it? I will get this 5. Then I will 8. Then I will get this 5. And then I will get this 2. So 8, 5, 2. And 2 times. So I will get 8 plus 5 plus 4. Which is 8 plus 5. 8 plus 9. Which will like 17. Okay. Now I will go to 9. 9. 9 cross 2 plus. Now I have to traverse till this area, till 8. Okay. Now again I am traversing for 2, 3, 5, 7, 8. Okay. So I can store this answer, right? I have traversed it maximum of 4, 3, 9. I can store this answer and I will skip that. I know that this answer is 9 for this array. You just have to calculate for 7, which is not needed because it's not more than 2 distance apart. And for 8 it's not needed. So till here I have already calculated. I can save it in some max element and it will be like maximum of these 3, which will be 9. So it will be 27. And for 10, let's traverse it. So I will skip this thing till 3 because it's 9. I will traverse the 7 now because I need to traverse it. Okay, so maximum of this 4 is, maximum for this 11, correct? 4, 3, 9, 11. So maximum of this is 11. So for 10, answer will be like 10 cross 2 plus 11. So it's 20 plus 31. Okay, 31 will be the answer. So till 7 I have traversed. If there is one more element 11 here, I will not traverse for 7. I will traverse. I have already marked the answer till 7, which is 11. I will say that I will traverse from 8. Okay, I will include the 8. So I will keep moving this. I will take one more pointer. Let's mark it like previous index or J pointer, something like that. And I will keep moving that and keeping this maximum element till here. Okay. I hope you understand the logic behind it, intuition behind it. And let's quickly code the solution which we have discussed now. And if there is any doubt, you can ask me in comments. Okay. So let's quickly take the size. Power dot size will be our elements. Okay. Let's create an ordered map. First of all, for frequency, an ordered map of int comma int. Let's name it frequency map, and let me take a vector of int of unique elements as well. Unique power. Okay. So let's traverse through each and every power here. Okay. I have 0, I less than n, I plus plus. I am traversing. I am checking if it is in the map, frequency map. If frequency dot find power of I, then to not equal to power frequency dot end. Then what will I do? And else what I will do? Okay, if I didn't find else condition, then obviously I will add it in frequency of power of I equal 1. I have seen it first, and whenever I have seen it at first, I will mark it a unique power dot pushback power of I. Okay, so I am getting these unique power made vectors, and I am making this frequency vector as well. Okay, otherwise, so this frequency of power I plus plus. So now I have this frequency map and unique power. Now let's sort this. Obviously, sorting of unique powers. Unique power dot begin, comma unique power dot end. So after sorting, we are done with our input part. Like we have a sorting array, we have a frequency map which we can look at. Now let's implement the algorithm. Implementation. Okay. So we have to return a long answer. So let me first make a variable long answer, which I will mark as 0, initialize as 0, and all the powers are like greater than 1. Okay, there is no negative powers here. Great. So I will return the answer at the end. I will not forget this. Great. My bad. Okay. Now how to implement this algorithm which we have done via this. Okay. So I was like traversing 1 and I was traversing 2 something previous index. Okay. I need 2 index. I need to index it. Let me make it index is 0 and like previous index is 0. Previous index till now index, or you can say anything, is 0. Let's make it max till now index, and I have to take this long max till now as well. Now max till now variable as well. Okay, I'm marking each one is 0 currently. Okay, so for int 0 I less than index, my bad, index equal to 0 idx index less than n. No, we can't go till n, we have to go till unique power dot size. Okay, now our n is changed, power dot size and idx plus. Okay, in that we have to check 2 things and we have to like mark answer. No, we have to mark the solution of max power of index till here, which will be like unique power of index dot its frequency of unique power dot index plus something x. Here it's not known till now. Okay, we have to do something like that. Okay, great. So we have to add this max till now. Now yes, max till now, we have to add this max till now, which will help us what will be the maximum element till now. Okay, great. So how to calculate this max till now? I have to calculate this. Obviously it will not be 0 forever, right? Otherwise it will not make sense here. Okay, so let's check if my max till now index is smaller than index, then it will make sense. Obviously for 0 it will not make sense. I will just add this max till now will be 0. For first element I will check max till now index is smaller than me and max till now index ka unique power. So at unique power of max till now index is less than, no, it should be plus 2, should be greater than, no, it should be 2 distance apart now. So unique power and unique power of, let me write something like unique power of index minus this unique power of power. So it should be like greater than 2. It should be 2 distance apart. Okay, if that's the case I will add it max till now. So max till now will become max of max till now comma max power till this max till now index, something like this. Okay, I will calculate max power at each index. I will take its smaller index. I will check what is the max power till here including that, and what is the max till now. Okay, I will take the maximum of all of this traversal. Okay, and I have to traverse it till end, right? I have to keep traversing until I found this key. Okay, I can't go ahead. So till now I have to traverse, so I will be traversing. I will use while loop here instead of if loop, if condition. Okay, and I will keep increasing this max till now index. Great. I hope this will make our array something okay. And how to calculate the answer? Answer will be the mix of all these index. Okay, so I will 0 I less than max power dot size I plus plus, and I will take answer equal to max of answer comma max power of I. So maximum of all of these max powers, I will check that what's the maximum I will get till now, and I will return the answer. I hope I have implemented this algorithm. So let's try to run this. Let's see, some array power of I not equal to, where I am using power of I, if condition. Here frequency dot find power of I. Okay, I forgot to add a bracket here. Dot end. There is one more bracket extra here. My bad. Max till now index 0. Too much syntax error I'm doing. What it is saying, max till now less than this, unique power. Oh, it will be like my bad. Unique power of max till now index minus this index should be greater than 2. Great. Max power, oh, I haven't defined max power as well, so I will define this vector of long max power is, what the size, I will add this unique power dot size. Okay, that's what I needed, not much than this, and 0 instead with 0. And wherever I am multiplying, I need to typecast it as well, right? I need to typecast this as well. So there is one more way. One, I will multiply it with one long, so it will be typecast to long, and it will be a long. Okay, let's run this now. Yeah, both the test cases are accepted. So let me walk you through this example which we have discussed in the discussion part. So let me make this array 2 2 3 5 7, what we have 8 9, then 9, then 10 to 10, for which we have the answer is 31. Okay, so let me also do output of this max power of I here, so we will understand that here something like this. So you will understand that what's the answer we have calculated, and is it matching our try run example. So for case 3, see, for 2 we have 4, then for 3 we have till 3 only, then 9, then 11, then 17, 27 to 31, exactly what we have calculated. So we have implemented this algorithm correctly. Okay, let's try to submit it. Yeah, it's accepted. I hope you found this problem interesting and solution challenging little bit of, but I hope you understood the solution. Let's optimize it. I'm seeing one more optimization I can make. I will take this max of answer comma max power of I here, so directly I can avoid this complete for loop. It will not like reduce our time complexity much, but it will reduce our number of operations. Okay, my bad. Okay, done. So let's try to submit this as well. Some mistake I have done again. Okay, it's index idx. Let's submit. Yeah, let's accept it. and you can see that we have some like moved from here till here. Some time complexity also reduced because we reduce one for loop. I hope I can know. Okay. So let's discuss this time complexity and space complexity of the solution, the last part. So we are doing here, we are making traversing till all n events. So n will be the time complexity for that of n. Okay, we are traversing each n element of power once here. Okay, we are making of n space till here for frequency and for unique power. So it's of 2n, but it will be marked as of n. Okay, then we are sorting. So it will, let's say we have all the unique elements already. Sorting will not make our, like, unique power is not smaller than n, it will be n. 8 it makes n, so it will be take n log n. So of n plus n log n plus, I will go down here for loop. I am making this index traversing through all these element ones, so O of n. But in this I am also making some while loop, but here you can see if max index will start from 0 and it will keep increasing. I am not going back, so it will be like O of 2n. Okay, so I am traversing one for idx, one for max till now index, so O of 2n, which will be like O of n. So summing all this up will make out O of n log n is the time complexity, and space complexity I am using O of n plus O of n for this makes power array. Okay, so it will be like O of n only. So in order of n space complexity and order of n log n time complexity, we have solved this problem. I hope you understood this approach. Let's meet tomorrow. Bye. Happy coding.